Okay, let's make a start. Good morning, everyone, and let's see if we can start really. Well, let me introduce myself meanwhile. My name is Daniele. I was a student of University of Padua, and I'm now an Android developer. I've been an Android developer for a while, and today I'm going to I'll give you a brief introduction about Google Cast. So, each one of us, when we think about how users are going to interact with the software we develop, assuming we are all developers here, every one of us thinks about different devices, depending on the project we are working on and depending on our experience. Maybe we are web developers or enterprise or desktop developers. In that case, users are going to interact mainly using a laptop or a desktop computer. If we are mobile developers, smartphones are the usual obvious choice, but maybe there are also some other more exotic, let's say, devices like tablets or smartwatches or smart glasses or wearables in general. But there is a device which is present for every single user, but is always ignored, which is the TV. TV is at the centerpiece of a user's home, and typically users, people in general spend several hours a day watching TV. But this, again, is something that we as developers often ignore, and we don't create apps for that. What I'm going to talk to you today about is Google Cast, which allows us to create and to show some of our service content on the TV, on the user TV, without even the need to create a dedicated app. We can already use the app we are already building, app or website, and just to enhance them, allowing some of the content to be displayed in the main display of the user, which is the TV. Let's have a look at the typical interaction that Google Cast allows to a user. One note here. I'm saying Google Cast or just Cast compared to maybe Chromecast. Who of you already heard about Chromecast in general? Okay, this is a small difference, but Chromecast is the actual physical device. Is that HDMI dongle that you attach to a TV to make them a bit smarter, while Google Cast is what we are talking about today, is the whole protocol, the whole communication suite that allows us to make into communication our apps, the existing ones, to the TV. So, usually a user is going to interact with Google Cast using a device, which they already know. In this case, it's a tablet, but could be a smartphone, or as we said, a browser in a computer. Then there is the receiver, which is the most common one is the Chromecast, which is attached to a TV, but could also be a smart TV, which already has the receiver inside, or a smart speaker, for example, if you are only dealing with music. And the other very important device is the sofa, of course. You really want a comfortable sofa to interact and to fully enjoy content on the TV. But given that we are developers and not a sofa manufacturer, we don't care about that one at the moment. As we said, the sender can be a mobile device with different operating systems. Android, of course, is the first one when you think about Google technologies, but actually Cast can be enabled also for iOS devices, and as we said before, also for websites, only if, of course, they are running, unfortunately, on Chrome, so no third-party options at the moment. The receiver is what is going to be displayed on the TV or run under the hood in a smart speaker, so that cannot be seen. But this one is typically just a web page. It's running HTML5 with JavaScript and custom CSS. So basically what is going to be displayed on the TV is just a regular website plus the usage of a Google library that we will see now. We need to consider also that maybe some of these, the TV is just the main example, but we have also other devices, for example, smart displays, and we will see later how these are going to be different. Let's have a look now at the main, the new thing that we are dealing with here. As I said before, Cast allows us to improve our existing applications, but something we need to create from scratch is the actual receiver, which is what is going to accept commands from our application and show something in the user's TV. As I said before, the receiver application is just a web page, so using JavaScript and HTML5. There are, however, different ways of creating it from the developer point of view. The main one is to use just the default one. This is very simple, and it doesn't require any work at all. It's fully hosted by Google. We don't need to do anything. It's already there, waiting for our application to send them some commands. The negative point of this is, of course, no effort to instantiate it, but no options to customize it at all. It's like it is. You cannot change not even a color. It just works. It's good for a proof of concept or for some hacking. But typically, you won't use it for a production environment. Something that is already usable for a final product is the styled receiver. In this case, the actual HTML page is still hosted by Google, but it gives us some opportunity for customize it. We just need to pass the URL of a CSS, and in the official documentation, you have all the classes that can be changed. And in this way, you can easily change colors, logos, how images are going to be displayed, some parameters of the player as well, because through CSS in JavaScript they can be read. And again, we don't have to worry about some hosting. We just need to worry about the customization. This could be already good for our product, our brand, in order to create a customized user experience. Finally, we have the most complex one, but of course also the most powerful, which is a fully custom receiver. In that case, you have to deal with everything. You have to host it, you have to customize it, and you have to deal with all the events, starting from the connection until the teardown of the cast session. Luckily, there are a lot of samples made by Google, so it's pretty easy to see how to create one, or to start with that one and extend it. Everything is built around, as I said before, HTML5 and JavaScript, and especially one library, which is called the Cast Application Framework, which gives us already a lot of callbacks for all the events. For example, when a user connects, when a second user connects, when the receiver receives a request for, I don't know, load a video, skip the video, pause it, etc. So it's pretty simple to extend it and customize it. When should you use it? Typically, the custom one, you want to use it when you want to deal with some custom logic. For example, DRM for the video, custom analytics, or maybe something that doesn't have to do anything with media. Because remember, the receiver application is just a web page. So maybe one idea could be to create a multiplayer game where the TV is the actual board and the user phones are just the controllers for that game. In that case, there is no media at all. You could just ignore the player in the receiver and have some WebGL canvas and just draw everything there. That would totally work. And again, you're not using media, you're just doing something custom, which you can only do with an hosted receiver. Something you need to consider as well is that cast receivers are not going to be loaded only on user TVs or Chromecasts. They can also be loaded into smart displays, like the Nest Home Hub. I never remember the name. In that case, you have a screen, but you also have touch support. So you have to consider that. Of course, there is a way to know it in JavaScript, so you can know if it's running and if it's supporting touch. But in that case, you should give clear and accessible touch targets to your users. Okay, so this is how you would create a receiver. But how would you extend an existing application? Now I'm going to show you some components, and I'm more focusing on mobile, specifically on Android. But this is just because I'm more used to that. Honestly, all the components are available for iOS, and they're basically the same. They're exactly the same, and also for web. That is going to change a bit of the UI, but the main concepts are all the same. So the first element the user is going to interact with is the cast button. That is a button that is going to be available and shown in your user application when a cast receiver is available. It has two main scopes. The first one, as I said, is to show the user what's the status of cast. And as you can see here, it's visible but not fully white, meaning that there is something available. There is a TV or a Chromecast available in the current network, but I'm not connected. Actually, this one is not the first state, because maybe your users, or yourself as well, are already using some apps that support Chromecast, but if you don't have any Chromecast receiver in the network, simply the button is not there. So this is one thing to remember. In case there are no devices available, the button should not be disabled, but should not be there at all. And for this reason, when it's available, the button should always be visible, not in some hidden menu or hidden panel. It should be present in the main UI of your application or website, because again, low discoverability. So in case if not, no devices are present, it's hidden entirely. If some devices is present but not connected, is not fully colored. And then there are some intermediate state, like when the user selects a receiver and starts to connect, when there is an animation. And finally, when the sender application is connected, it's going to be fully colored. This was for mobile. For web, there are different options. The user can interact with different buttons. For example, if you are dealing with creating a website which involves video playback, you might want to use some players like the YouTube one that integrates a cast button. Or you can create a custom UI for that. For example, in the Spotify website, they are creating a different separate panel for casting to different devices. And then here you can see they are not supporting only Chromecast, but also other technologies, which makes totally sense. Finally, the user always has the option with Chrome to interact with Chromecast using the Chrome menu. In that case, the default is to cast the whole content of the web page to the TV, but also there is the option from there to cast only a video, in case it's a video playback page. All these three options, they are always leading to the appearance of a new menu, which we will see also now for mobile, which is the cast dialog menu. In this dialog, this is the version for Chrome, while this is the version for mobile. And this dialog allows the user to, at the beginning, select which receiver they want to connect to. Again, this dialog is going to change depending on the status of the cast connection. This is for selecting which receiver to connect to. This is in case a receiver is connected but still not playing anything. While in case something is playing, here we want to show some information, and we already want to allow the user to change something about the playback. So you can see here, for example, there is the poster of the media being played, some information like the author, the title, the TV or the receiver name, but also the user here already can do something. They can pause, they can change the volume, they can already interact with the playback. This is a first level of interaction, but it's very limited. What an application should do when playback is starting is to actually show a dedicated control. And of course, if you are, for example, a media playback application like YouTube, you don't want the phone to play the same video that you are watching in the TV. When cast starts, you want to stop the video on the phone, just show the controls, maybe some information about the receiver, and then let the Chromecast receiver do their job. The expanded controls, they allow to do more things and more interaction with the receiver. So for example, here you can see they are, a user can pause, can scrub to a different location, and can see more metadata regarding the currently played media. This is just one example implementation, the one that does YouTube. Here you can see only the first part of the UI is dedicated to the controls, while they want the user to be able to browse for other stuff. You want to keep the user engaged more and more, to keep them watching videos because that's their business. Another implementation, which is the one that I did for Channel 4, the British broadcaster, is to have a dedicated full screen activity for the expanded controls. In this case, you can see we are just not only displaying media metadata, like the poster, the title and subtitle, we can also allow the user to scrub to different positions, but also we are showing where the adverts are going to be. Okay, this is good when the user is using the phone just as a remote, basically. But as we said, we want the user to be hooked into our service. We want them to consume more stuff. So why not let them browse our app for the next thing to watch later? In that case, while the users are gonna browse our app, we still want to let them know that something is playing and they can still interact with it. This is done through another component which is called the mini controller. As the name suggests, it's a very, very small version of the extended one, which gives the user most of the screen space for the main concept of a main UI of our app, but still showing them some status about what is playing. This again is just one example from YouTube, but for other applications, this one is the one we did. You can have a different UI, or in this case, we just use the one from the Google Cast SDK, which is a library, and it already allows us to show some information. Something I forgot to mention is that all the components that you saw, the button, the dialogue, and the mini controller, and also the expanded controllers, they can be totally customized, which is recreated from scratch using your language you use for develop, or you can just use the implementation from the SDK. In that case, you already have some working components which can still be styled. Like the colors that I showed you, they can be totally changed without having to re-implement everything. You can just pass some values, some resources in case of Android, or some colors in case of iOS, and you already have something totally working. You don't have to worry about the life cycle. You can just style it to match the rest of your application. Okay. This is fine while the user is still inside your app. But let's say a boring scene is happening on the movie that they are casting. Maybe they want to check some other messages or some emails on the phone. In that case, they can still know what is happening through the cast notification. This is a system level notification that is going to show again what is happening and allowing the user to do some basic interaction like play, pausing, skipping, etc. The actions here are totally customizable, and you can select what are the ones allowed to the user. Of course, we hope that the content that the user is watching on the TV is entertaining enough so that they don't want to stay looking at their phone. So let them put the phone away, but maybe sometimes they want to check if they have new emails or new messages. Again, even from the lock screen of the phone, they can have a look of what is happening. So lock screen, they can be more customized in Android compared to iOS, but also in iOS, some information are shown. The biggest difference here is that on Android, here you cannot see it very well, but basically the background is styled depending on the poster of what is casting. Last component is volume control. As we saw before, the user can use the phone or their tablet as a remote, and then they can also change the volume of the TV without using yet another remote. Something good to do here is to use the phone physical buttons that by default they are going to be intercepted and change the cast volume. This is something that can be done for free. You just need to enable it with a flag. One last component that is only available for Android are playing intent. These are something which is something great to have the user explore even more, interact even more with your services. The main concept here is that if I'm home and I'm watching a video on my TV using Chromecast and my girlfriend comes home, she will see a notification saying, hey, another device is playing this element or this something on the TV. And she's going to click on that notification. There are two options. Default one is to show the Google Home app, which is giving some information already of what I'm playing. She can already turn down the volume, pause it, or stop it. But something good to do with playing intent is to drag her inside the application already. So this is a good way to introduce new users to an already casting application without them to have to browse them on the launcher, on searching on the phone. Okay, now that we saw the two main actors on a cast environment, which is a receiver and sender, let's see how they are interacting with them. Everything starts with a phone or mobile device which is scanning for a nearby device. Usually this one is done in the background, in case of Android using at the system level with Play services. So something I didn't mention before, Google Cast is only working on devices with Play services. So not for OnePlus devices or Amazon Fire devices, but let's say it covers a lot of devices around here. The phone uses different technologies to look for these devices. Network scan, but also Bluetooth, low energy, proximity, and also ultrasounds. Once a device is found, the cast button is displayed, and at that point, the user can select the receiver they want to connect to. What is going to happen here is that our application, or better, the Cast SDK, is going to communicate through the connector to the receiver and is sending just an application ID. This is a short string, less than 10 characters, that is saying, okay, Chromecast, just go and fetch this application. The Chromecast or the receiver is going to ask the Google backend to say, okay, give me the URL, because we said before the receiver application is just a web page, associated to this cast application. And then the application is loaded and displayed on the phone, on the TV. Now, this connection can happen in two cases. The connect and play case and the play and connect. As the name suggests, connect and play means that the user was not playing anything, was just browsing our app. A receiver device was detected, and they connected to it. At that point, the receiver is loaded and stays there, idle, maybe showing some logo, some animation for our service, but it's not doing anything, actually. It's waiting for a new command to actually start playing. At that point, our application is going to send, when the user selects a video in our list, the data needed for the receiver to load it. The other scenario is that the user was already playing something on their handheld device, and at that point they start a connection with the receiver. What happens here is that the receiver is going to load, but immediately is also starting to play the content which the user was already watching on the TV, on the phone. The key here is that the experience needs to be seamless, meaning that this is not automatic, but it's very simple to do. We need to pass to the receiver the exact position, the exact seconds of the playhead where the user was playing. Meaning that if I was looking at a scene here on the phone, the same scene is going to continue on the TV with no interruption at all. And of course, we need to manage locally on the phone that the fact that we don't want the playback to continue there as well. On the phone or tablet or browser, as we said, there we just need to show the controls. The playback is only going on the TV. Once the playback starts, we can use the Cast SDK or the Cast Application Framework in order to send and receive media communication media control messages. In this case, the main commands are, of course, play, pause, scrub, change the volume, etc. Something we need to remember here is that our device, our application on the sender side is going to receive updates from the receiver. And that is very important because the receiver needs to be the source of truth for what is going to play. This is because, as I mentioned before in the me and my girlfriend example, you can have a separate user come in later while there was playback and sending new commands. So for example, say I'm playing a video, okay, and I'm having my controllers displayed on my phone. If she comes and she scrubs at the end of the video, then the controls needs to be updated on my device as well. You have to remember this because cast has this very small complexity, but we just need to remember it. You can have as many senders as you want, but the receiver is going to be always the source of truth for both the playhead status, the media metadata, and also any other custom status that you want to deal with. Another example is when you stop. So cast can stop for different reasons. For example, from the notification, or from the cast dialog, or also from third-party applications, for example, the Google Home one. In that case, it's very important to deal with that gracefully. So for example, if we are casting and we are showing the controllers in one device, and we are stopping from another device, then we should close the controls also in the first one. We don't want the user to be left there like, oh, I can still see the controls, but if I play, nothing is happening on the TV, what's happening? The whole experience needs to be consistent across all the devices. Another thing very important is that the user should be able to resume on their device at the same time where they left on the TV. So again, remember to synchronize the playhead status between, and also the rest of the status between receiver and sender. These are the most common use cases when we are dealing with media. The cast protocol also allows you to send custom messages, in this case in the form of JSON messages with a custom namespace. And this can be very useful in case you are creating a custom application which doesn't deal with media in general, like I said before, or if you want to send more data. So for example, in the Channel 4 Android application, we are using custom messages to send more metadata, more analytics from the sender to the receiver and vice versa, and also more information, for example, all the advert breaks, which advert breaks have been watched, etc. And this is very powerful because, again, you have some callbacks through the SDK from both in the sender and the receiver, and you can just deal with that by parsing and mapping the data that you are receiving through JSON to what you need. Okay, there is just one last component to make everything work, which is how you register a receiver application. As we said before, the receiver, when receives a connection request, is going to ask Google, okay, I just received this, where is the, okay. I just received an application ID request. What's the URL? That URL is defined in what is called the cast console. This is a console where you can create several applications, and for each application you can specify which kind of receiver you are dealing with. If it's a styled one, in that case you need to pass the CSS for the customization. If it's a custom one, you need to pass the URL of the actual web page to be loaded. As I mentioned before, the default one doesn't need to do anything because it cannot be customized and it's hosted by Google, so there's not even an option for that. Once you create the application, you can customize it passing more parameters. So for example, you can specify some Android intent for the intent to join. You can pass some other data. And something is very interesting and you need to remember is the status of the app. Meaning if the app is published or unpublished. By default, while you are developing it, the app is going to be unpublished. And if you try to look at it from your phone or your desktop, you can see that the app is not visible on the list of available receivers. Actually, the cast button is not even showing. So before starting to wonder if your Wi-Fi is okay, if there were some network issues or something else, it's important to notice that here, the cast button is only going to be visible if your app is using the correct application ID and the app is published. Or in alternative, you can add your Chromecast or cast receiver device ID to this console. In that case, your device ID is going to be whitelisted, and even if your app is not published, so not visible to everybody on the internet, you can still debug it and you can still test it and use it, but only on your device. Speaking about testing, unfortunately, there is not an automated test framework for custom. The most automated thing is a spreadsheet. I'm not joking, which you can find in the official custom documentation. There is the URL here. I'm going to share the slides later. And despite not being automated, it's a very completed and very extensive suite of tests and scenarios that you should cover when developing a custom application. It covers all the possible scenarios, including multiple senders, different operating systems between the same session, etc., etc. So you should really cover all these scenarios, or at least most of them, in case you want to publish a fully finished custom application. One last point is about debugging. If you are creating a custom receiver and something weird is happening under the hood, you might want to understand what's happening there. And for this, the Chrome web tools are your best friends. You can just use Chrome Inspect, and if your Chromecast device is whitelisted, as we said before in the cast console, it's going to appear here under Chromecast when your application is running. At that point, you can debug it like you were debugging a local application in your web browser. So you have the console, the layout inspector, and all the things you are used to when debugging web pages locally. This is very powerful, but again, remember to whitelist your device, otherwise it's not going to appear here. Okay, so in conclusion, remember that, okay, here we are. Oh, no, too quick. Okay. Remember that the custom application framework is your best friend. It's an SDK that covers most of the common use cases and is very simple to customize. Of course, you can recreate everything from scratch, but the SDK is going to give you most of the things you need and cover especially a lot of edge cases and common lifecycle scenarios. There are multiple options for the receiver. Think about if you need to really cover some custom logic, or maybe a styled receiver is enough for you to change it, to style it to the brand of your service. Remember that multiple senders are allowed. So the receiver needs to be the source of truth, and every sender needs to be reactive to the updates that they receive from the receiver. Finally, custom messages, they can provide a richer experience. So if you want to have more analytics or more data shared between the receiver and sender, you can always create your own custom protocol with ease. And then remember to follow the testing checklist, because even if it's very long, it's good because it covers all the different scenarios. And that's it for today. Thank you very much. If you have any questions, I will accept some questions now. Or you can ask me later. See.
Yeah. How does it work, the notification part for the websites?
Mm-hmm.
You can customize that or not?
In that case, it's not by default. So Chrome is not going to show any notification by default using the custom application framework, but you can create it through JavaScript. So again, using the SDK on your website, you can have some callbacks when the status changes. So when the user connects, when the media playback status changes. So in that case, you can create your own notifications in the website. But it's not something that is done by default by the SDK. Okay, thank you very much.